Shami. Introduction of household income and expenditure, HIS. The function of HIS is to provide data on household income, expenditure, and socio-economic indicator. The purpose of data catalog is to centralize resources for district-level HIS data and support socio-economic analysis and decision-making. HIS is hosted by Department of Statistics Malaysia, and their key feature is to access comprehensive district-level statistics and to promote transparency and data accessibility. His target user is to policymakers, researchers, academicians, and the public, and the application is to analyze income distribution, living standard, support policy development, and socio-economic planning.
Hi everyone, I'm Song and I will now present the data description part of our project. This dataset contains 160 observations and add variables, which including both the numerical and categorical variables. The categorical variables are date, stage, and district. The numerical variables include income mean, income median, expenditure mean, Gini, and poverty. This dataset offers insight into income distribution, poverty level, and income inequality, making it a valuable resource for understanding regional economic trends.
Hi, I'm Theo, and I'll be talking about the methodology of our assignment. For this assignment, we have decided to use Principal Component Analysis, or PCA. In PCA, each principal component is a linear combination of the eigenvector of the correlation matrix with the variables. We have decided to use PCA because with PCA, we can get dimensionality reduction, and we can easily identify trends, patterns, or outliers in our data. Furthermore, with PCA, we can preserve the maximum amount of variance in the data. With that, we can identify the most important variables for socioeconomic indicators. Now, let's move on to data pre-processing. PCA only works with continuous data. So, this is what our data looks like. We have date, state, and district that are not continuous. So what we do is we remove the date and the two categorical data. So we are left with a data set with 5 variables, which is income mean, income median, expenditure mean, Gini, and poverty. Now, our data is measured in different scales. So, to make our analysis easier, we standardize the variables.
Hi everyone, I'm Xavier, and I will be continuing on explaining the overall procedure what we have done after standardizing the household data. Since we have chosen to standardize the data, we will proceed with finding the correlation matrix instead of the covariance matrix using the core function. After that, we find the eigenvalues and corresponding eigenvectors of the correlation matrix we constructed earlier using the eigen function. For the obtained eigenvalues, we assign them into a data frame arranged in descending order. This is important for the step later, which is forming the script plot. We plot the script plot using the ggplot function from the ggplot2 library, which we loaded and attached at the very beginning of the coding. Script plot is significant to determine the dimensionality reduction, which relates the steps later on. Consequently, we perform the PCA, Principal Component Analysis, on the household data using the PRCOM function. We then print out the result for further analysis and understanding. Subsequently, we undergo the normality test of the retained principal components after observing and analyzing the script plot earlier. Based on the script plot, we have decided to only keep the first 2 principal components. Hence, we will only be checking the normality of the first 2 principal components by performing the Shapiro-Wilk test and QQ plots. Last but not least, we will detect and identify the outliers by calculating the Mahalanobis distance for each observations. It is based on a chi-square distributions of 5 degrees of freedom and significance level of 0.025. For better visualization, we have decided to plot a scatter plot of PC1 versus PC2, where we can observe the outliers in the plot. So that's all for the methodology of this assignment. And now that I have said that, I will hand the presentation over to my teammate. Thank you.
Then we will continue with the results, starting with eigenvalue and eigenvectors. The largest eigenvalue 3.3359 identify PC1 as the direction of maximum variance. The smallest eigenvalue 0.0052 indicates that PC5 contributes negligible importance. See the script plot. The arrow appears after PC2, confirming that PC1 and PC2 dominate the variance. PC3, PC4, and PC5 expand far less variance, making them less critical. Therefore, in this case, retaining PC1 and PC2 would be sufficient. We also computed the summary of PCA results, show that PC1 has the highest standard deviation at 1.8264, and together with PC2, they capture 89.42% of the total variance. This means retaining only these two components is sufficient to represent the datasets.
Hi, I'm Tom and I will present for the normality and outliers of the PC. From the QQ plot, you can see that the points in PC1 is S-shaped and it deviates from the red line, which means that PC1 is not normally distributed and the data has skewness. On the other side, the points in PC2 does not deviate from the red line, and we can say that PC2 is normally distributed. And the Shapiro-Wilk test is another way to test the normality. And based on the Shapiro-Wilk test, p-value in PC that are less than 0.05 indicates that the data is not normally distributed. From the table, we can see that p-value for PC1 is 1.703 d-7, which is way lower than 0.05, indicates that PC1 is not normally distributed. And the p-value for PC2 is 0.8678, which is much greater than 0.05, indicating PC2 is normally distributed. And the observation in PC1 and PC2 are plotted in a scatter plot with the outliers highlighted in red color. And the outlier is actually the observation with Mahalanobis distance, which is greater than the threshold. And the exact value of the outliers are shown at the table below.